Hello students, I thought of recording a short introduction video to today evening's lecture. Today we're going to talk about the population models. So let's think about different populations. It can be a human population, it can be a fish population in a pond, or it can be an alligator population, or it can be a population of lions in a forest. So what can be interesting to the people is how would such a population change over the time. So we know that we can explain this using, since it's a population change over time, we should be able to represent it as a differential equation. Anyway, so now let's think about some events happened in New Zealand and Australia. So the rapid population has been invasive in the New Zealand since the late 19th century, and some rabbit has been identified as a major agricultural pest, and they thought of like, yes, we need to take some action on it, we need to control it. So they started control it in late 1800. And similarly in Australia, we know that the camel population has become an issue. So in early settlement time, people use camel for transport and transportation stuff, but not nowadays. People don't need camels anymore, but people have seen an increase in the camel population, and so the Australia had to take some camel culling program starting from early 2000. That's because to reduce the environmental damage, and also to come up as a solution for this scarce water resources for the areas which has small rainfall. Okay, so that means if we sort of like know how certain population would change over time, it can be quite useful for us to take a decision. Okay, now how can we exactly represent a population model? In our lectures last week, we explored actually one model which called the exponential growth model. According to that model, we assume that the population grow over the time, how exponentially grow. So does that apply all the time? That's a question to answer. Let's find a solution. So if we think about the human population, we know that the human population, if we think about the entire globe, the human population has been grown over the time with the improvement of the life conditions and the technology and all sort of things, and has been increased and increased and increased. But do you think it's going to be exponential increase? No, I don't think so. I don't think so, because it's going to be changed. The people have predicted that after, I think after 2060 or 2160, I don't exactly remember when, this population growth is going to come to a maximum point and then become lower, because we know that the people now having less children than the number of children people had before, due to different reasons so what would be the other models that one can think about to represent a population more accurately? So especially in case there's limited resources, or there are some other factors that affecting the population change. or also there can be some population, there are some population, there were some populations in the world which has been extinct over the time. For example, the population of mammals, sorry, let's say dinosaurs or something like that. Okay, so in this lecture what we're going to do is we're going to explore different basic population models that people have developed and explore their accuracy, where we can use them, sort of things, so that one can make changes to these population models to more accurately represent a population of interest. Thank you. See you during the lecture.